Hello viewers, in today's class we are going to solve yet another important problem from three-dimensional geometry, right? So here the topic of discussion is the shortest distance between two lines, right? So here we are to find the shortest distance between these two lines, right? So here let us first denote the two lines as L1 and L2, right? And we have already discussed the detailed concept of shortest distance between two lines in our earlier videos. So here we are going to solve this problem by making direct use of the given formula, right? So now we know that the formula which is used to find out the shortest distance between two lines is given by this expression, that is the absolute value of vector a2 minus a1, and here we'll have the dot, and this is b1 cross b2, and then we'll have the magnitude of b1 cross b2, right? So we are going to use this result to find out the shortest distance between these two lines, and here we'll explore the notations a1, a2, b1 and b2. So viewers, here we are given the Cartesian equation of the two lines L1 and L2, right? And here we know that the vector equation of any line is given by vector r, and here we have vector a plus lambda times vector b1, and here lambda is a scalar, and this vector b1 is the vector to which the line L is parallel, right? And this vector a, it denotes the point through which the line passes, right? So now here when we apply this formula, we can change the equation of these two lines in the vector form, right? So here the vector equation of the line L1 can be written as vector r, and here this point that is vector a can be written as a1 vector plus lambda b1 vector, and L2 can be written as vector r. Here we have vector a2 plus mu b2, right? So these are the equations, or the vector equations of these two lines L1 and L2. And here if we take the line L1, then vector a1 is given by the point through which L1 passes, right? So the point is 3i cap plus 8j cap plus 3k cap, right? And the vector b1 is given by the direction ratios of this line L1. So here we have 3i cap, then we have minus j cap, and then we have k cap, right? So these are the two vectors, vector a1 and vector b1. Similarly, vector a2 is given by the point through which this line L2 passes. So here we have minus 3i cap minus 7j cap plus 6k cap, and vector b2 is given by the direction ratios of this line L2, which is minus 3i cap plus 2j cap plus 4k cap, right? So now we have vector a1, vector b1, vector a2 and vector b2, right? Here I would like to mention one important thing, that whenever we convert the Cartesian equation of a line into vector form, then we must keep one important thing in our mind, that is the the equation of the lines should be given in this form, right? That is x minus x1 over a, y minus y1 over b, and z minus z1 over c. And here we see that the equations of the two lines L1 and L2 are perfectly given in this standard form. And in case the lines are not given in this form, then before writing the vector equations of the lines L1 and L2, we must reduce the equations, the Cartesian equations of the two lines in this form, right? And once we write the equations of the two lines in this form, we can easily identify the vectors a1, b1, a2 and b2, right? So now to find out the shortest distance between these two lines, we have the four vectors and we can easily find out these three quantities. So now viewers, let us first find out this quantity, that is a2 minus a1, right? So here we have a2 is minus 3i cap minus 7j cap plus 6k cap, and here we have minus 3i cap plus 8j cap plus 3k cap, right? And this is minus 3, so we have minus 6i cap, and here we have minus 15j cap because this is minus 7, this is minus 8, and here we have 6 minus 3, that is plus 3, right? So now vector a2 minus vector a1 is minus 6i cap and minus 15j cap plus 3k cap, right? Now let us find out the second one, that is b1 cross b2, right? So this is the cross product of vector b1 and b2, and this is given by this determinant, that is I cap, j cap and k cap. And here the first row is occupied by I cap, j cap and k cap. The second row is occupied by vector b1, so we have the components 3, here we have minus 1 and here we have 1, right? And the third row is occupied by b2, and here we have minus 3, here we have 2 and here we have 4, right? So here we have 3, then minus 1 and then 1, and here we have minus 3, then 2 and 4, right? Now we can easily expand this determinant. So we have I cap, then we have minus 4 minus 2, then we have minus j cap, then we have 12 plus 3, and then we have k cap, and this is 6 minus 3, right? So we can write here we have minus 6i cap, then we have minus 15 j cap, and here we have 3 k cap, right? Now let us find out the dot product of a2 minus a1 with b1 cross b2, right? So b1 cross b2, and here vector a2 minus vector a1 is given by minus 6i cap minus 15j cap, and then we have 3k cap, right? And this vector, that is b1 cross b2, is given by minus 6i cap minus 15j cap plus 3k cap, right? And now the dot product of these two vectors is given by minus 6 times minus 6. The II components will be multiplied, and then the JJ components, that is y components, minus 15 into minus 15, and then we have the z components. So we have 3, and here also we have 3, right? So this is 36, this is 225, and this is 9, right? And if we add all these three numbers, we'll get 270, right? Now let us find out the magnitude of B1 cross B2, right? So the magnitude of B1 cross B2 is given by square root, and here we have B1 cross B2 as minus 6i cap minus 15j cap plus 3k cap. So here we have minus 6 square, then we have minus 15 square, and then we have here 3 square, right? And now if we solve it, then we have minus 6 square is 36, then we have 225, and then we have 3 square is 9, and this is square root of 270, right? So now we can substitute all these values in this formula. So now the shortest distance is given by the magnitude of this dot product. So A2 minus A1 dot B1 cross B2 is 270, and the magnitude of B1 cross B2 is square root of 270, right? And this can be written as 270 over square root of 270, and this can be written as square root of 270, right? And if we simplify it, then we can also write it as 3 times square root of 30, right? So viewers, the shortest distance between these two lines L1 and L2 is 3 times square root of 30 units.